Let Z17 be the ring of integers modulo 17, and let Z17x be the group of units of Z17 under multiplication. Which of the following are generators of Z17x? So we're provided with the possible, provided with the, the options 5, 8, and 16, but some combination of them could be true. Right. So what are the, first of all, what are the units of Z17? Oh man. Ooh. So on the one hand, one way we could figure this out, it's partially by the process of elimination, but I can just take these numbers and keep multiplying them by themselves. And well, I don't even know if these are all units necessarily in Z17. Hold on. Which of the following are generators? So this is where I'm even forgetting a little bit about the definition of a generator. In order to generate a group, doesn't that mean that a single element can be exponentiated, or it can be raised to a power to give all the elements? Okay, so 16 is a unit because 16 is equal to -1 mod 17. So 16 squared is equivalent to 1. So in fact, 16 is its own inverse. But if there are other units, then 16 clearly can't be a generator because 16 only generates itself and 1. Is there another easy way to find units? So what's another, how do we find another unit? Okay, well, 3 times 6 is equal to 18, which is equal to 1, or equivalent to 1. So doesn't this mean that 3 and 6 are both units? And so then doesn't this immediately mean that the correct answer to this is either A, none, or, oh, it can't be E. Yeah, it cannot be E or D. Okay, yeah, 3 and 6 are both units. Okay, hold on. 2 and 9. 1, obviously. 16. Like I feel like I'm basically on the verge of brute forcing this. I just don't. anymore have the knowledge of what kind of theorems would be useful to do this. I mean, so these are all the units that sort of come from 18 in an easy way. What's the next? 17 times 2 is 34, so 35. Wait a minute. A unit is something that you can multiply it by something else to get, oh, 3 times 5 is not 35. What am I doing? 7 times 5. Okay, there we go. That makes more sense. Seven times 5 is 35. Seventeen times 3, what is that, 51? So I'm looking at factors of 52. This is 2 times 26, but that's already 2 times 26 is 52. 26 is 9 mod 17. So wait, does that mean yeah, okay. So the other thing to realize is like these units sort of like come in pairs, right? Like, hold on, another way of thinking about this. Sixteen matches with 16. 1 matches with 1. Every other number has to come in pairs. Every other unit, at least, has to come in pairs. So the number of units is even. Well, is there another number that could square to give 1? Is that possible? Hum. Is 8 even a unit? How do I get, how do I multiply 8 by something to get 1? So we have 18. 18 plus 17 is 28. 35, not a multiple of 8. 35 plus 17, 52, not a multiple of 8. Plus 17, 69, not a multiple of 8. Plus 17, 86, not a multiple of 8. Plus 17, 103. 120, that's a multiple of 8. That's 8 times 15. I mean, if I take like powers of 5, so what is 25 mod 17? 8? Let's write it like this, 25. No, the numbers will get too big too quickly. So 5 squared is equivalent to, so it's 25 minus 17 is 8. 5 cubed is equivalent to 40. 40 is equivalent to 6 mod 17. 5 to the 4 is equivalent to okay, 30 minus 17 is 13. So 13 is also a unit. So the answer could potentially be 5. Could potentially be, I mean, hold on. What is the thing that pairs with 5? 7. So 7 to the 4 mod 17 is what pairs with 13. Well, 6 pairs with 3. So 3 times 7 is 21. 7 to the 4 is equal to 21 times 7. Hold on. 6. 6 pairs with 3. What does 8 pair with? 15. 7 squared must be equivalent to 15. Yep. Wait, is that right? 34 plus 15. Yep. 7 to 4. So 3 times 7 is 21. 21 mod 17 is 4. So then 5 to the 5. 13 times 5. 65. Mod 17. 14. 7 to the 5. 28. Mod 17 is it 11? Yep. Yeah, like I don't like that I'm brute forcing this. Five to the 6, 14 times 5, 70. 70 mod 17 is 2. So that means I've already found the pair for 2. That's got to be 9, but let's just make sure. 7 to the 6, 11 times 7, 77 mod 17. Okay, let's write out multiples of 17, would make this easier. 34, 51, 68, so 68 plus 9 is 77, yeah, so this works. 5 to the 7 is equivalent to 10. 7 to the 7 is equivalent to, oh yeah, I didn't find the pair for 10 yet. This is really tedious. There's got to be a smart way of doing this. But not here. 9 times 7 is 63. 63 mod 17 . 63 mod 17 is at 12. Man, are we ever going to get back? Are we ever going to see like a common number here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The next one, so 5 to the power of 8 is 50, which is 16. And so 7 to the power of 8 must also be equivalent to 16. So what happens to 5 to the power of 9? 16 is negative 1. Negative 1 times 5 is negative 5. Negative 5 plus 17 is 12. So now we get to 12. And we probably go back down. So 5 appears to be a generator. 7 to 9 must then be equal to 10. And let's verify that here just in my head. That's negative 1. Negative 1 times 7. Negative 7. Mod 17 is 10. Yeah, so 5 goes up this list like that to 16. And then it's probably just going to go down this list and hit everything. So 5 is a generator. And based on the options given by process of elimination, this means that the answer must be B, that this is the only, of the 3 numbers given here, this is the only generator. 7 is also a generator, but that's not one of the options. And we know that 16 is not a generator. And so, yeah, I mean, like, I really don't want to go through the same sort of analysis with 8 itself to show it must miss some numbers. I mean, I guess multiplying by 8, you would get 8, 13, 2, 16, and then you would go down 9, 4, 15. So you'd miss a lot of them. I don't know what theorem needs to be quoted here to figure this out very quickly. I'm sure there's got to be something, but I do not remember this stuff at all. So yeah, ended up brute forcing it here. I'll check my answer to make sure that I'm correct. but I'm pretty sure I am. I've essentially listed all of the units along with their pairs and the way that they're generated by the number 5. So that's enough for me. But yeah, I'll let you know if I find a mistake. Thanks for watching.